Welcome to Atmospheric Tales, a podcast that amplifies stories and experiences related to air pollution and climate change from around the world. I'm your host Shazad Ghani, and welcome to another episode of Atmospheric Tales. Our interviewer for this episode is Denise Tukey. Denise is a postdoctoral research officer at the Grantham Research Institute on Climate Change and the Environment at the London School of Economics and Political Science. Her work focuses on the mobilization and uptake of climate information for decision making, such as for disaster risk reduction or climate adaptation. Since she's from Trinidad and Tobago, a lot of her work has naturally focused on the Caribbean small island developing states, but she also does comparative research on other islands and the UK. She has a PhD in Sustainable Development from Columbia University and postgraduate degrees from Columbia University, the International Institute of Social Studies of Erasmus University Rotterdam in The Hague, and the University of the West Indies in Trinidad and Tobago. Our guest today is the Coordinating Director of the Caribbean Meteorological Organization, CMO, Headquarters Unit and the Permanent Representative of the British Caribbean Territories with the World Meteorological Organization, WMO. She is well known in several areas of meteorological research, such as tropical meteorology, thunderstorm systems, flash floods and mitigation, and satellite meteorology. She is the author of several publications, including Introduction to Tropical Meteorology, as well as a co-author of the award-winning Meteorology of Tropical West Africa, the Forecasters Handbook. Prior to joining CMO, she was a scientific analyst at the National Oceanic and Atmospheric Administration's Earth System Research Laboratory. Earlier, she has worked as a forecaster in Jamaica and as a scientist at the US National Center for Atmospheric Research. She has also held various academic positions, among which assistant professor at the University of South Florida and adjunct professor at North Carolina State University. I'm excited to welcome our guest, Dr. Arlene Laing. Welcome to the show, Arlene and Denise.
Thank you, Shazad, for that lovely intro and, of course, for having me here. And welcome, Dr. Arlene Laing. It's an absolute pleasure and honor to be interviewing you today.
Thank you both very much. Thanks, Denise, for agreeing to be the interviewer, and to Shazad for inviting me to join this podcast.
Our topic today is on climate change and extreme weather in the Caribbean. And according to the World Meteorological Organization, there have been more than 11,000 disasters due to weather, climate, and water-related hazards over the past 50 years. These have contributed to the deaths of more than 410,000 people in the past decade, the vast majority in low and middle-income countries. In the recent past, the Caribbean has faced frequent and often intense climate-related hazards. And we know that many of these events have caused disaster-related impacts that deeply affect lives, livelihoods, communities, and economies. Dr. Laing, can you give us a brief background into some of the various threats affecting Caribbean islands and maybe some of the challenges that are presented as a result?
So the Caribbean is one of the most hazard-prone areas in the world. We are, of course, prone to tropical cyclones, which are called hurricanes within our region. And we've had a number of very extreme events in recent years, with Category 5 storms affecting many of our islands, especially since 2017, where we had Irma, Maria, Dorian, and this past year in 2020, where we had several Category 5 storms, such as Iota and Eta and Laura. All of those storms, of course, with the Greek names, indicating that we had exhausted the regular list of names and had gone into the Greek alphabet later in the season. But those systems were extremely strong events in terms of wind speeds, but they also caused quite a bit of flooding. Now, outside of the hurricane season, we also have events that are extremely deadly and catastrophic as well. And even within the hurricane season, you can have events that are not hurricanes that lead to tremendous amount of damage and deaths. So in 2013, for example, just around Christmas time in the Eastern Caribbean, there were floods that affected St. Lucia, St. Vincent and the Grenadines, and Dominica in particular, leaving some 18 persons dead and billions of dollars in damage. And that was from a series of slow-moving severe weather storms that produced quite a lot of heavy rainfall, damage to the airports, for example, with an airplane landing from Virgin Atlantic in St. Lucia at the same time that the river burst its banks and flooded the airport. So we've had quite a bit of threat. We also have Sahara dust as a major air quality and public health disaster that can happen when you have very thick dust outbreaks. We have strong winds, rough seas, and swells. And swells can occur not because of systems that are within the Caribbean, but systems well to the north can lead to swells in the ocean that end up affecting the eastern and northern parts of our islands in the eastern Caribbean in particular. So we have a number of hazards that we have to deal with.
It's just so interesting to hear about this wide range of threats and impacts within the region. What are some of the actions required before and after an extreme weather event?
Well, first of all, if you want to have a successful early warning system, you have to consider the various components. And generally, they're thought of as having 4 pillars, where you have the risk knowledge, and then you have the warning and communication component, the preparedness and response. And so in terms of what needs to be done, you have to understand your risk ahead of time. So there has to be research that is done to understand, for example, how many hurricanes do you normally have for the year? When do you normally have droughts, for example? What are the things that influence drought? So you have an idea of when we do have droughts, how long do they last? What's the reduction in percentage of expected precipitation? When you're having swells, what time of year do you have your rough seas and swells? So you have an idea of the risk, and then you can use that risk information to determine what the action should be. And you get information now in terms of monitoring that risk, and you use that information to give your predictions. And then you have your appropriate response that has been developed by having a preparedness put in place ahead of the event. And for folks to also understand the impact of that forecast. So when we talk about categories of storms, of tropical cyclones, those are based on wind speeds and what those wind speeds will do to infrastructure and vegetation. So the idea is that you understand not just what the weather is going to be, but what the weather will do. And that's called impacts-based forecasting. And that helps to determine what kind of action will be taken in response to an extreme event. If you understand, if someone says there's a category 3 storm, you know that there's a particular range of wind speeds and what that range of wind speeds will do to your buildings and your vegetation and your power lines, if there are power lines with poles above ground, and those will be taken out. So that's an impacts-based forecast. When someone says expect a category 3 tropical cyclone, there is lots of coordination that has to go in. Within each island, there's a connection, of course, between the meteorological services and the national disaster agencies. And that's where that first communication goes. And the disaster agencies are then having the scope and the mandate to describe what the communities are to do in response. And then when an island is overwhelmed, then they, based on the level of threat, they communicate that to the Caribbean Disaster and Emergency Management Agency, that's SEDEMA. And then SEDEMA then has this regional response mechanism that can respond to the appropriate level of threat in each member state. In terms of what's going on with assistance that we can get from elsewhere, we do have facilities such as the World Bank or the World Meteorological Organization that assist our region in preparing. First of all, in preparing our forecasters to understand what kind of weather is prevalent within our region and how to forecast those better. And then we have the coordination role of the Caribbean Meteorological Organization among all of the member states. We have 16 member states, English-speaking Caribbean, and we have 2 organs. There's the headquarters unit in Trinidad and Tobago and the Caribbean Institute for Meteorology and Hydrology, which is in Barbados. And they're the technical and training organ, among many other things. And between us, there's a coordination of joint activities and technical activities in weather, climate, and water services. We do a lot of coordination rather with the World Meteorological Organization through the Regional Association, which is covering North America, Central America, and the Caribbean. And one of those areas is, for example, the Hurricane Committee. So one of my predecessors, Mr. Egbert Berridge, was a really strong early advocate for the formation of the Hurricane Committee. And we are now in the 43rd year of the Hurricane Committee. And this brings together all of the countries that are affected by hurricanes within our region. And that extends all the way from Canada to Cape Verde, to Venezuela, to El Salvador, Mexico. And we come together once a year to review our operational plan and our technical plan. And within that operational plan, we have agreements where there are backups so that if one island is affected, someone else takes over forecasting and warning for them, and so on. So the CMO's role is to really help to coordinate those agreements and to have also formal working arrangements with the WMO and with our colleagues within the regions such as Meteor France, which enables our national Met services to be able to access observations and products and services, and especially model output that they wouldn't normally be able to afford to procure for themselves as individual countries. And this enables our forecasters to really provide better services to our region. We are no longer surprised by a tropical cyclone because we have good monitoring systems. We have coordination that is led by the National Hurricane Center in Miami, which is a WMO regional specialized meteorological center.
Sometimes we forget or we just don't know that there's such a complexity to understanding and responding to extreme weather events. So I find this was a really comprehensive overview of what takes place in the Caribbean. But you mentioned something that I thought was really interesting. You said a lot of this has to do with understanding risk ahead of time. And right now we live in a world where many of us are acutely aware of the threat of climate change. Can you walk us through the connection between climate change and extreme weather events?
Well, first of all, I should say that the science of attribution of specific events is still an active area of research. I know as humans, we like to see patterns and we think we see a pattern and we immediately run with that, but this is still an active area of research. What I do want to say is that we can learn from studies of climate trends that of what might be possible and what might be coming on the different climate scenarios in our future. So one of the things that we look at and often gets a lot of play is the number of tropical cyclones within the Atlantic. That's where we are in the Caribbean. So last year we had record-breaking numbers of storms, but globally, the numbers of storms did not change. And so this is something I always like to remind people. So while the Caribbean and the Atlantic had a very busy season, dreadful for especially the central Caribbean countries, the Pacific was much quieter. And so globally, we're looking at an Earth system. So globally, there isn't a dramatic change in the numbers of the storms. But we have other factors that are actually influencing the numbers of storms within the Atlantic. For example, the Atlantic multi-decadal oscillation has a big impact on this period of what we call relatively quiet that ended in 1995. And now we're in this more active period of tropical cyclone activity within the Atlantic. And that's a different phase of the Atlantic multi-decadal oscillation. One of the things that also is interesting is in the Central America, in the latter part of the season last year, became much more dangerous because we had switched our interannual variability into what's called the La Nina phase. And with La Nina comes many more major hurricanes within the Caribbean. And that's what we saw starting in September. We had switched into a La Nina phase. So I just wanted to let that be known that we don't just attribute extreme weather events to climate change. We do have these other variabilities that impact the numbers of storms within a season, and whether we get more of those stronger storms will depend on things like El Nino, La Nina, and the multi-decadal oscillation. And we also have a dependency on whether or not we have strong Sahara dust outbreaks. So in the early part of the season last year, we had unprecedented Sahara dust, some of the thickest dust that had ever been monitored and recorded. And during that period, we had much weaker storms. And so the challenge of attribution is to determine what is climate variability and what is climate change. So I would say that one of the areas where we understand what climate change is doing is in terms of a warming ocean and what it does to precipitation. So with a warmer ocean, you do tend to have more precipitation because more warming means more evaporation, and more evaporation leads to more efficient precipitation from tropical cyclones and greater rainfall rate. So with your more intense rainfall, then that means, of course, more flooding. And one of the things that has been found in looking at climate trends, not only in the Caribbean and North America, but elsewhere, is that there's been found that tropical cyclone movement from 1949 to 2016 has been decreased by about 16% over land areas. Now, what does that mean? So over time, the climate is changing so that your tropical cyclone movement is slower. At the same time, you're dealing with a warmer ocean. So what you're doing now is having greater rainfall rate with slow movement of tropical cyclones when they make landfall. So then you're having, of course, much more tropical cyclone rainfall in a given area. So with that, you end up, of course, having much more flooding, both from the coastal storm surge as well as from inland flooding. With this additional fuel, as you would say, from the warmer oceans, hurricanes can really produce a lot more rainfall even after they make landfall. And that can lead to flooding and landslides. And that's what we see in Central America. But the good thing, I should say, perhaps I might be getting ahead of myself, is that we have learned from the past in that when a hurricane like Mitch happened in 1998, this was also a year of the La Nina, and the numbers of deaths in Central America were on the order of tens of thousands as it lingered over the region for 5 days and produced a lot of rain, something like 1,900 millimeters of rainfall. And the damage was about $6 billion US. Now, in 2020, we had critical warnings several days in advance, and that basically reduced the numbers of deaths to the order of hundreds, like 200 and something so far confirmed. That is a huge difference, orders of magnitude better. So our early warning systems have allowed us to improve the outcomes in terms of fatalities. That doesn't mean the region doesn't suffer economically, because we know that the infrastructure from the flooding and landslides that ensued does have an impact economically. But we have made great progress in terms of people being at risk for dying and for casualties in terms of injuries and so on. So with Iota and Eta affecting the same area that Mitch did in the past, we can say that we have made some improvements through these early warning systems and through understanding what can happen with more flood-prone tropical cyclones, and understanding from our improvements in hurricane prediction that we can provide better warnings.
This is all really fascinating. First of all, I think this is great that you've clearly identified and shared with us this difference between climate change and climate variability, but also sharing with us just how the progress of early warning systems in the region has reduced at least, the numbers of people at risk within the region. Very interesting. We know that many islands in the Caribbean are still naturally exposed to various climate-related hazards, and within a changing climate, reports like the IPCC suggest that there is still a high likelihood that some of these extreme weather events will become more frequent and more intense. Turning now to think about climate change and this changing climate, what are some of the additional burdens that Caribbean communities might face? And what is the role of climate adaptation in this context?
I'd say our region is, in terms of what sectors our economies depend on, we remain really vulnerable. We are many small islands surrounded by a large ocean, or rather sea. And we have, of course, the burden of tropical cyclones as a major event, which is a system that is born over the warm ocean. So that's one reason why we're so vulnerable. But we also have vulnerability to sectors such as agriculture that are based on rain-fed agriculture for the most part, especially for smaller islands. And in some places, they're dependent on irrigation, canals, and so on. But for the most part, we're talking about rain-fed agriculture. And so variability in seasonal and even sub-seasonal rainfall can have a major impact on agriculture. We are very dependent on tourism, and so you must have infrastructure in place when you're bringing in millions of tourists into your region. They're coming for recreation. A lot of recreation is coastally based over the water. So you need to be able to adapt to ensure that your coastal areas remain as you would like them to be. But in a changing climate, if you have stronger tropical cyclones creating more strong winds and coastal erosion, then that affects the economic livelihoods of the people along the coast. And most of our populations do live along the coast. Most of our critical infrastructure are capital cities with major financial infrastructure are along the coast, except for Belmopan, which was a deliberate decision to put that country's capital inland from the first city that used to be along the coast. But for the most part, we're talking about the needing of water resources, and that's a long-term climate outlook. So in the future, based on research that has been done by the University of the West Indies Climate Studies Group, we're looking at drier, more severe droughts. And so our islands, for example, in the Northeast Caribbean that are very dependent on having rainfall be available to them we're looking at Tiga and Anguilla, these islands that have very little rainfall to begin with. If we're looking at a drier climate, what are they going to be doing? They need to invest more in alternative sources of fresh water, maybe more desalination plants. And so there has to be strategic planning for things like that. If you're looking at a future with less fresh water available from rainfall, you are also looking at public health. If you're looking at the future where you may be getting more Sahara dust outbreaks because rainfall in West Africa will be different, then you're looking at respiratory illnesses. You have to determine then how much money will be spent on the necessary medications that people need to have. That has to be ordered with the idea that you're going to expect so much more respiratory illnesses in a particular season. You have vector-borne diseases that are related to climate, such as dengue from the mosquito, the Aedes aegypti. You have chikungunya. You have a number of these things. Mosquitoes, their population increase based on temperature. If you get above 18 degrees Celsius in some places, you have a proliferation in mosquito populations. There are different kinds of thresholds that we now understand that lead to proliferations of these kinds of vectors that bring diseases. So we have to think about that. We have to learn how to adapt our agriculture. We had a scenario in 2009 to 2010, which was a kind of a wake-up call for the Caribbean because there wasn't a seasonal outlook that indicated drought, but there was a disconnect in terms of how that information translated into action on the part of agriculture. So out of that grew the recognition that we needed to follow the WMO Global Framework for Climate Services, which is meant to provide governments and sectors with advanced information about climate outlooks so that they can be better prepared. And there is a dialogue between the climatologists and the stakeholders to determine what each understands about the other's need, because it's important for the stakeholders to actually understand that climate information can be useful for them. And not all stakeholders are aware of that. And so it's an education process as well.
Thank you so much for all of these insights, Dr. Laing. It's fascinating to hear about how we think and how we need to move forward with thinking about climate information and climate change, and also adapting to this changing climate within our region. I'm sure many of the listeners will appreciate this information so far. But I want to mention that while there are similar challenges faced across different islands and even across island regions, there are also many differences. Can you share with us what makes the study of weather and climate impacts in islands so unique, but sometimes so challenging?
I think one of the things that I like to let people know when they see global maps, for example, of this is the climate in the future, 2050 or something, that those models are not able to resolve our islands. They're basically interpolating what is a large grid box down to a small island. And you cannot really attribute specific things until you start to do your modeling on the scale of where you're trying to make your decisions. And so with technology and with scientific advances, we've been able to increase the resolution of our global models. We're also better able now to understand some of the uncertain aspects of modeling. So clouds, for example, are not well defined in global models because global model cannot define a single cloud. Even the most sophisticated high resolution model cannot define a single cloud. So you have to do what are called parameterization, which is you try and figure out how to represent the effects of the cloud within that model. So these uncertainties are within your modeling that you're developing. And so within islands, especially the mountainous islands, there can be quite a bit of change as you go from coast to mountain peak between your dry side of your island, your leeward side, and your windward side. So we recognize, of course, that in an island like Barbados, the east coast of Barbados is much more rugged than the west coast. And so those kinds of subtleties are not available to a regular operational model because they can't resolve those things. So what you need is for what we call downscaling, taking the information from the larger scale model and adapting it to what you should expect based on what you understand about the physiography of your island, the geography of your island. And this is where we need to have adequately trained persons and scientific advances that really focus on those smaller island perspectives. because we need to understand the vulnerabilities that will come with, say, a drier climate. So as I mentioned before, the example of Antigua and Anguilla and the countries in the Northeast Caribbean, for them, water availability is a major, major problem. But when you come to Jamaica or Trinidad and Tobago or these other more mountainous islands or Hispaniola, your concern is flooding that is due to orography enhancing rainfall. So the hill that is facing the wind is leading to more rising air as the wind hits the high terrain. So one side of those larger islands gets a lot of heavy rain. And so we need to understand those variabilities. At the same time, you have your rain shadows. In Jamaica, where I'm from, is in the southwest. And in the southwest part of St. Elizabeth, my parish, it's very, very dry, but it's actually one of the most prolific areas for agriculture. And it's because the people learn to adapt to the dryness by using drip irrigation and using mulching. So they keep the little water that they have and they produce melons that are amazingly large. And you'd think that this melon had come from a place that naturally gets a lot of rain, but it doesn't. But the people themselves have adapted. So one of the things that I like to ensure that people know is that the local people themselves should be part of this discussion and part of the conversation. And it's something I know that Adrian Trotman of CIMH, he's the Chief of Applied Meteorology and Climatology, and he specializes in agrometeorology. And he will tell you that the farmers themselves, when you talk to them, when they're expecting a very wet season, they will build a mound so that the water drains away. When it's drier, they will change the way they build so that the water drains inward. And so our local people themselves are able to develop adaptation techniques. So we need to have that dialogue with them. We just need to provide the information and understand how they themselves have been adapting through the years. And we have indigenous communities in Guyana, for example, where they've been learning how to adapt through thousands and thousands of years. And so there is this need to learn what's already been done from our indigenous communities, our local communities of farmers, and then help them also to understand where some of their own indigenous knowledge might not be enough, because we understand from working with indigenous communities that some of the things that they understand as indicators of seasonal variability, that some of those indicators are no longer applying because of changes in our global climate. And we do have research gaps, such as over the ocean. We're now in the start of the UN Decade for Ocean Sciences for Sustainable Development. And we are, as a region primarily of ocean, in need of understanding better our marine environment. We have very little in the way of in situ observations in the ocean, in the Caribbean. We need to really better understand our marine environment to be able to use it effectively for resourcing economically and for sustainable development in terms of making sure that our coral reef environments are not affected by acidification or effluence that is coming from the land, and keeping our coastal environments also sustainable so that we can keep our fisheries intact. And we do have policy that has to be guiding this as well. So our governments and leaders need to develop policy that ensures a sustainable blue economy, a sustainable green economy, a sustainable tourism economy. Essentially, we need to also mix our economies, because we learned from the pandemic that importation of food is really, really a problem. We've known it for some years, but it was really brought to the forefront when you have countries being closed and a reduction in global trade and the exchange of goods slowed down. And there is a recognition that we really need to do more on our own. And for agriculture to succeed, you really need good climate information. You need good climate information for renewable energy, which is another growing area that is important for reducing our dependence on fossil fuels. There's quite a bit going on, and it does require an understanding of what our practitioners bring to the table in terms of our forecasters. It does require what understanding our researchers bring to the table by having them be able to get the information that they need. Data sharing is really important. We need to have sharing of data across disciplines. You cannot provide an impacts-based forecasting if you don't have information about the impacts. So if you're trying to forecast flooding, flash flooding in an area, you need to understand that, well, there's been some development in the area recently that's changed the hydrology. who has the hydrology data? Is it shared with the Met Services? Or is there some kind of an understanding for the Met Services to be getting information directly from a hydrological service? If they're two separate agencies, they need to have this kind of collaboration because they're both speaking to the same group of stakeholders. So there needs to be a lot done in terms of multidisciplinary connections to meet these challenges that we face in the future in the Caribbean.
I am really appreciative of all of these local insights and understandings that you're sharing with us. And I hope that some of this information encourages listeners out there to become more interested within the region and within this field and, fill some of these research and policy gaps that you have mentioned. In this way, though, I'm turning to a more slightly personal level. I'm curious to understand how you became interested in science and specifically in meteorology. How did your background in Jamaica influence your professional choices?
I was a bookish child. So I actually got a book as a prize when I was 9 years old at primary school. It was entitled The Weather. It's part of the Ladybird series that comes from England. I'm not even sure if it's produced anymore, but it was simply titled The Weather. And that was sort of how I first became fascinated. There was, all about different kinds of clouds, the Beaufort scale, and so on. And then on to high school, when I was in third form, the equivalent of ninth grade, we had a really good geography teacher. And I should say my high school was a boarding school. And so he had us getting up early in the morning to record the pressure, the temperature. We learned how to read our wet bulb thermometer. We didn't have an anemometer. We used the Beaufort scale to estimate the wind speeds. So we kept the journal and we had our Caribbean weather map book that you could track hurricanes and learn about drawing isobars. And so that was me at 13 deciding that's what I wanted to do with my life. I wanted to be a meteorologist because the seed was planted when I was 9 and then it flourished when I was 13 and I decided that's what I wanted to do.
Well, it's a good thing for that book. I wonder if it still exists and maybe we should get a copy of it somewhere. But you've clearly pursued since then, since that early understanding of it, you've clearly pursued a successful scientific career and you currently hold a leadership position at the WMO, a place where we still see few women. Can you kindly share with us some of the challenges and of course successes that you've experienced along the way and maybe offer some insights for a few of us?
In terms of challenges, I was used to from an early age to being one of few. In my A-level physics class, I was one of 2 girls and there were 15 boys. So I have 2 older brothers as well. So in that regard, I'm a bit different from some of the other people, perhaps. But I should say that one of the things that I learned was to always be curious and not let other people tell you that you can't do this thing. Because I think one of the messages that we were getting, myself and my friend, was that if you were a girl in science, you had to be super bright. You had to kill yourself to do this. But there were guys in my class that were not told the same message, that they had to be super bright to be in physics. But it was a message that girls were getting then. But thank goodness we're not getting that anymore. But that was one of the challenges, in that to do science, you were told that you had to be super bright if you're a woman. I think everybody who is interested in science and wants to go far has to maintain a level of curiosity. So that's in terms of having a successful scientific career. But the success is not only based on curiosity, it's based on finding mentors who can help you along the way. And I've been very fortunate in the mentorship of my professors through the years. My graduate professor, Professor Mike Fritsch, was really, really a huge influence on my life. And he was very much strongly focused on making sure that whatever research we did, that it got a lot of promotion. And he would ensure that all of his students would publish their research and that he was not the lead author. The student was always the lead author on his publications for his students. It was very rare that you would see his name at the top of a publication. It was always Laing and Fritsch in my graduate work publications. And I've done the same with my students. When I had graduate students, I ensured that they were involved in that process and that their research was publishable, that it was of good quality and high quality so that it would be published. And then that would lead to opening doors for them. Mentors are really important. Having someone ahead of you tell you about that journey and also to be on the lookout for you. So when I became a professor at the University of South Florida, I actually found out about that position because of Dr. Eve Gruntfest. She was a visiting scientist at CIRA, which is a Corporate Institute for Research in the Atmosphere at Colorado State. And I was doing my postdoc. And she is the kind of person that does not let you just be. She wants to find out how you're doing, what you're interested in doing. And she just walked into my office one day with this job announcement. And he says, "This job looks just like you. I know the head of the department. You need to apply." And so someone like that is really helpful. And I've done the same for other people since. Wherever I found opportunities, I connect them with people. And when I was away from the Caribbean and I would find out about something, I provide that information to others in the Caribbean so that they would have access to those experiences and those capacity development opportunities. So I think as women move into leadership positions, we try to do that for the others, because one of the reasons we also have a difference in the numbers of women is the time lag of a pipeline. That's just the basic idea. So one of the things I found out recently in participating in an AMS webinar was some statistics were shown. What we're looking at in terms of women having greater numbers of PhDs is that cohort are people now in their 30s, where you have a larger percentage of women now in their 30s. Everybody older than that, who are heads of institutions and at that very, very senior level and emeritus level, that is a smaller percentage of women. That pipeline started with those pioneering women who have since retired or have passed on. But that pipeline was mostly filled with the people who came before them, which are mostly men. So now we're starting to see a difference where the women who are in their 30s now will be moving into leadership positions and can develop a pipeline that will have more women. So I think we can be optimistic in that the pipeline is just a lag.
Indeed. And I think it's such a positive thing to say that we're looking forward to the future and having this pipeline, as you say, of pioneering women in the future. And it's also heartwarming to hear about your conversation of mentors and that you yourself also want to do the same for your students. I think that's really lovely and it's really pleasing to hear. One thing, though, you said that something that you find probably a mantra or something that you kept connected to is always be curious. And in that, one of the things those at Atmospheric Tales found out, this fun piece of trivia about you, that you are the creator of the first Jamaican website on the internet. Can you share with us some details about this pioneering work and this honor, this curiosity that you had, and perhaps your thoughts, if I may, on the use of the internet for climate communication in the Caribbean?
First of all, I should say that was not on the internet so much, but on the web. And I didn't have the first website, but I did have the first website that provided information about Jamaica in general, because the University of the West Indies was already online. This was in 1994. I was in graduate school and I was shown Mosaic, which was the first web browser that I'd ever seen. And as soon as I saw it, I was like, this is it. The world is going to change forever. And I also knew that it was a really good medium for meteorology, which is a very visual science. So I knew immediately that this was going to be the future. One of the first things I did was they had a short course at Penn State in the computer science department. It was like an afternoon. And I started building my own website in 1994. And then I did one for my high school. The reason I ended up doing the one for Jamaica was actually I used to provide presentations on Jamaica within the Penn State community, not just on campus, but to schools and so on. So I had a lot of material already about Jamaica that I used to bring with me. And I actually had an outfit that my mom made, a Jamaican folkloric outfit. And so I had already a lot of information about Jamaica. So it was a really small leap to use my newly found HTML skills at that time to make a website about Jamaica. And I didn't even know then at the time that it was the first. But I ended up at one point almost bringing down the server of our college because I had linked what was then Yahoo, which was one of the first places that collated websites. And so many people were coming there that I had to remove that website from the college server. It was overwhelmed. But I really enjoyed doing that because I saw the potential for the use of this medium for information. We now know, of course, that it can be used for a lot of misinformation, but certainly in terms of climate communication, we can, and we are doing this already, providing a lot of climate communication via the web. Most of our Met services have websites. The 5Cs, the Caribbean Community Climate Change Center, has online the capability for someone to go in and look at scenarios for their understand what is my climate risk. The University of the West Indies has their SMASH tool where you can look at if you had a hurricane like Gilbert hitting your island, what would be the impact? And you can do that kind of scenario animation online. And so this is a use of the World Wide Web, that visual part of the internet, for communicating climate information. And it is being done and we need more of it.
Thank you so much. That was, for me, very fascinating and so good to hear all of these views. Thank you so much, Dr. Laing, for being here.
So thank you very, very much, Denise, for allowing me to join you in this episode of Atmospheric Tales. Thank you, Shazad, for the invitation to participate. I do hope that our listeners will have learned much about the Caribbean and our unique situation in terms of hazards and the particular vulnerability that we have for climate change.
With that, I would like to thank our guest, Dr. Arlene Laing, and our interviewer, Dr. Denise Tukey, for joining us on this episode of Atmospheric Tales. Thanks to all our listeners for tuning in. Make sure to subscribe and share.